जी, आप स्टार्ट कर सकते हैं।
ठीक है। Subir, Shivam and Ansaj are here. So today
Yes,
we'll
sir.
be doing solar power plant. Good evening, everyone.
Good evening, ma'am.
Good evening, Ansaj. Open your camera. Subir, who is working in solar plant?
हम
मैम,
रास्ते
शिवम,
में
मैम।
5 मिनट में पहुंच जाएंगे मैम। सॉरी
अच्छा
मैम,
अच्छा अच्छा अच्छा, ठीक
हम
है।
5 मिनट में पहुंच रहा हूँ, 5 मिनट में।
अच्छा,
हाँ हाँ।
so what is a solar plant? Here we are using power from the sun to make electricity. So the solar power plant is also known as the photovoltaic power plant. It is a large-scale PV plant designed to produce bulk electricity power from solar radiation. So you're using solar radiation is being converted into electric power because all the other ways of producing electricity is now becoming very difficult to do it because it is using a lot of natural resources. Solar energy is something which is always there. The solar power plant uses solar energy to produce electrical power. Therefore, it is a conventional power plant. It is not, it is a conventional power plant. Solar energy can be used directly to produce electrical energy using solar PV panels, जो हम लोग ज्यादातर देखते हैं रूफ टॉप पे भी लगे रहते हैं. So we are quite familiar with solar PV panels. Or there is another way to produce electrical energy, that is concentrated solar energy. In this type of plant, the radiation energy of solar first converted into heat or thermal energy, and from there you produce the electric, and this heat is used to drive a conventional generator. What is generator they do? They convert it into electrical energy. This method is difficult and not efficient to produce electric power on a large scale. So this method, that you are first converting into thermal energy and then you are driving the generators to produce electricity. So this is very expensive and it's not very efficient also. So we generally use this photovoltaic power plant. Hence, to produce electric power on a large scale, solar PV panels are used. So this is a solar power plant. You can see from here sunlight is coming, and these are the PV arrays, photovoltaic, and then these are the inverters. Then you have battery to store the charges. Then you have the grid, transformer, the tower lines, the transmission tower lines. From here, it is through this transmission line, it is transported to various destinations wherever it is required. So what is the photovoltaic principle? On what principle does it produce? From solar radiation, it is producing electricity. So this is a bit technical. Even I am not from this field. I think whoever is working in this field would be able to explain it better than me. Who's working in solar plant? Shivam.
Yes, ma'am. I'm working, ma'am.
So you explain this to us.
Yes, ma'am.
Read it and explain it to us.
Okay, ma'am. Silicon is the most common used material in solar cells. Silicon is a semiconductor material. Several materials show photoelectric properties like cadmium, gallium, arsenide, etc. Electron hole pairs are created in solar cells. The PV materials have the property to absorb protons of sunlight. The valence band electrons of semiconductor materials are at lower energy, and the electrons of conduction band are at high energy level. The difference between this energy level is known as band gap energy, EG. When sunlight falls on solar cells, the difference between photon energy E and band gap energy EG is absorbed by the cell, and it excites some electrons to jump across the band gap. These electrons move from the valence band to the conduction band and create holes in the valence band.
So explain this, explain to us in a simple language, because it is
Ma'am,
something,
basically,
the difference in the energy level.
Yes, ma'am.
And the electrons being absorbed by the
Transferred from, in this basically, ma'am, we are using the cells. In a panel, cells are there, small cells are there. When जब sunlight मैम cells में पड़ती है, तो electrons are transferred from negative terminal to positive terminal. मतलब इसमें यही चीज लिखी हुई है कि नेगेटिव से पॉजिटिव की तरफ इलेक्ट्रॉन्स ट्रांसफर होते हैं. और जितना ज्यादा ये बैंड गैप जो होता है फोटोन एनर्जी का, जो डिफरेंस होता है फोटोन एनर्जी का और बैंड गैप एनर्जी का, उसके बीच में इलेक्ट्रॉन्स ट्रांसफर होते हैं, और जितने ज्यादा इलेक्ट्रॉन्स ट्रांसफर होंगे उतना ज्यादा वोल्टेज हमको मिलेगा पैनल से.
What about the others? Have you understood it? Subir, Ansaj?
Yes, ma'am.
It is clear. It is the difference between the energy level.
Therefore, if the potential difference exists within the cell, the electrons of the conduction band and holes of the valence band made the flow of current in the circuit possible.
So because of this phenomena, the difference between because of the potential difference, it is possible to make the electron flow in the circuit, and electrical energy is generated. So what are the components of a solar power plant? The major components of the solar voltaic system are listed below. One is naturally photovoltaic panel, PV panel, which is known as PV panel. Then you need inverter.
Battery.
Then you need energy storage devices. Then you need charge controller. Then you need system balancing components. So one by one, I'm showing these components and you explain it to us, Subir. Shivam, sorry.
Yes, ma'am.
So this is the components. Here you have the sunlight, you have charge inverter or charge controller, then you have the battery, then you have the monitoring system, you have the transformer, then and it is being transmitted to residential and commercial power utilization through transmission lines. The first is your photovoltaic panel. Shivam?
Yes, ma'am. PV panels or photovoltaic panel is the most important component of solar power plant. It is made up of small solar cells. This is a device that is used to convert solar photon energy into electrical energy. Generally, silicon is used as a semiconductor material in solar cells. The typical rating of silicon solar cells is 0.5 volt and 6 amps, and it is equivalent to 3 watt power. The number of cells is connected in series or parallel and makes a module. The number of modules forms a solar panel. According to the capacity of power plant, a number of plates are mounted and a group of panels is known as photovoltaic array.
What we see actually, it is the photovoltaic, that blue panels. Then next comes your inverter.
The output of the solar panel is in the form of DC. The most of load connected to the power system network is in the form of AC. Therefore, we need to convert DC output power into AC power. For that, an inverter is used in solar power plants. For a large-scale grid-tied power plant, the inverter is converted with a special protective device, and a transformer is also connected with the inverter to assure the output voltage and frequency as per the standard supply.
Because what does the inverter do? It either increases or decreases the voltage. So it converts into the
DC to
voltage
AC.
where it can be used commercially. The inverter converts the DC current into AC current.
AC current.
That is from the direct current to alternative current. We have all studied this in school, that there are two types of current: AC current, DC current. So most of the appliances are all today we are using AC current, but the which is being produced in the photovoltaic is DC. So we have to convert it to AC, and that is what the inverter does. Energy storage devices.
The batteries are used to store electrical energy generated by the solar power plants. The storage components are the most important components in a power plant to meet the demand and variation of the load. This component is used especially when the sunshine is not available for a few days.
So you have to, because sunshine is something which is not constantly available. We have to store it somewhere. So when it is not available, then also we can use that power for running our various equipments.
The capacity of a battery is that how much amount of electrical power it can store. The capacity of batteries is measured in ampere hour rating. For example, a battery having 10 ampere hour battery can supply 1 AMP current for 100 hours or 100 AMP current for 1 hour.
It is what? 100 ampere hour. So it can be both ways. 1 for 100 hours,
100 hours or 100 for 1 hour.
100 for 1 hour.
For a long life of a battery, never fully charge the battery. And in case if a battery is fully charged, never keep fully discharged battery for a long time. The capacity of a battery is affected by the temperature. There is a reduction of 0.6% of capacity for every degree Celsius raise in temperature more than 25 degrees Celsius.
So the optimum is 25. So after that, it starts losing its capacity.
There are two types of batteries used in a solar power plant. Lead acid battery and nickel cadmium battery.
Then you have the charge controller.
A charge controller is used to control the charging and discharging of a battery. The charge controller is used to avoid the overcharging of the battery. The overcharging of a battery may lead to corrosion or reduce plate growth, and in the worst condition, it may damage the electrolyte of the battery.
So you have to keep the charge in the battery at a certain range. So there you need charge controller for that.
Sometimes the controller is termed as a solar battery charger. There are many technologies used to make a charge controller. For example, the most popular technique is the MPPT charge controller, that is known as maximum power point tracking. This algorithm is used to optimize the production of PV cells.
So this is a bit technical. I think Subir might be able to explain this.
No, I am also not getting this MPPT because we are making the panels only. We are not
You're
generating the
making the
electricity. Solar panels are there. We are generating the panels.
so you can think that there's number of techniques for making this charge controller. One of them is MPPT, which is maximum power point tracking. I don't know why it has hanged.
Good evening, ma'am.
Good evening.
I'm just reaching in my home. I think there is some problem, no? Madam screen is not showing.
Hello, can you hear my voice?
Ma'am,
Yes, madam. But
Yes, ma'am.
your screen is not
No, but
visible.
I cannot share the screen.
Yes, that is the problem.
That is the problem.
ma'am,
It
Megha
says
is the host, ma'am.
Most
Actually,
disabled
Megha is the host.
participant screening share. I'm not a participant. I was made the host.
But here looking, Mega is host.
Here it is shown that Megha is the host.
Yes. So I think. Yes.
How that has been. Megha. Meghna. Hello. Meghna. Meghna, can you hear me? Hello. Hello, Meghna.
I'll call her.
Can you see the PPT?
No, ma'am.
Huh?
No, ma'am.
No.
Because I cannot share it.
Ma'am, Meghna can approve you. Meghna is there. She can approve you.
Meghna, make me the host.
I think we have to start once again, na? Once again, madam, I think you have to log in again.
Okay, I'll do that. Should we? I'm leaving and then I'll rejoin.
Yes, madam. I think it will be better.
Hello, Meghna. You make me the host.
Hello.
Hello. The problem is I cannot share the screen because Meghna is the host now. And she is not responding.
Ma'am, we will all leave and again we will come in the. We can all leave and again we will start.
Okay, all of you leave and then again start.
Okay,
Okay,
ma'am.
ma'am.
Ah. Now you can see the PPT.
Yes, ma'am.
Yes,
Now
sir.
I can share it. So we were talking about charge controller. Then system balancing component. Shivam?
Yes, ma'am. It is a set of components used to control, protect, and distribute power in the system. These devices ensure that the system working in proper condition and utilize energy in the proper direction. And it ensures maximum output and security of other components of a solar power plant.
So explain this.
मैम ये एक्चुअली में सिस्टम बैलेंसिंग सिस्टम वो है जो अपनी बैटरी से रहती है, बैटरी हुआ, सोलर पैनल हुआ, उनका वोल्टेज को फ्लक्चुएट होने से बचाता है. मतलब एक प्रकार का एक प्रोटेक्टिव लेयर रहता है कि ये अगर कुछ फ्लक्चुएशन ज्यादा होता है या संदेश ज्यादा आ गई या फिर बैटरी ज्यादा ओवर चार्ज हो गई तो ये उसको बैलेंस करके उसको डिस्चार्ज कर देता है. ये एक कंपोनेंट होता है मैम जो कनेक्टेड रहता है इन्वर्टर से.
हाँ, नहीं तो वोल्टेज भी ज्यादा हो जाए या बैटरी डिस्चार्ज कर जाए तो यू विल हैव प्रॉब्लम्स.
इट इज मतलब एक लेयर है, मतलब एक कवच लेयर है कि ये सबको प्रोटेक्ट करने का काम करता है.
सबको प्रोटेक्ट करने का काम करता है. Then blocking diode.
The solar PV panels are connected with a battery, and these panels are used to charge the battery during sunlight is available. During charging of the battery, the current flows from panel to the battery. But when the sunlight is not available, the current can be flow in reverse. But when the sunlight is not available, the current can be flow in the reverse direction, and it may harm the solar panel. So the blocking diode is the diode that is connected between the battery and the panel to avoid reversal current from battery to the panel.
This is quite easy to understand. Because when there is sunlight, from sunlight it comes to the panel, but when there is no sunlight, it will be reversed and that will harm the panels. So blocking diode is used. This is sort of a diode is so that it is not reversible. The flow of current is not reversible.
Yes, sir.
Then you have voltage regulator.
Voltage regulator. The output of solar panels depend on sunlight, and the sunlight is not constantly available. It is constantly varying. This results in fluctuation in load current. The voltage regulators are used to maintain fluctuation within an acceptable range.
Because you need the voltage in an acceptable range. अब ये तो नेचुरल है, तो ये तो नहीं होगा ना कि सनलाइट एकदम एक ही तरह से कोई मशीन से निकल रहा है. It is not under our control. But
Yes,
in our control is to stabilize it. Voltage regulator se we regulate the voltage. Like for example, everything has two components. One is your controllable and another is uncontrollable. So here the sunlight which is reaching the panel is uncontrollable. That is not under our control. But we can regulate the voltage by using voltage regulator so that no harm is done to the transmission or other parts of the solar plant. So now here is an example how solar PV system is designed. Solar PV system design can be done in 4 steps. First is load estimation, how much you require. Estimation of number of PV panels. For producing that much of load, how many PV panels you will be. I'll be using a very simple example. You can always, that is the numerical values, if you change, the answer will change. But you should know how it is being calculated. Estimation of number of PV panels, estimation of battery bank, cost estimation of the system. Given base condition is that this is a very simple thing, only 2 CFLs, 18 watts each, 2 fans, 60 watts each for 6 hours a day. First is your energy requirement. For this, running 2 CFLs
and 2 fans.
And 2 fans. And how much energy they'll be using, that is also given to you. So the total energy requirement of the system, total load, that is total connected load to PV panel system, is number of units into rating of equipment. So you know it is 2 CFL.
Into fans are there.
2 CFL and 18 watts. And this is 2 fans, 60 watts. So total is 156 watts. This is the required load. Then watt hours. Watt hour is what? A measure of electrical energy equivalent to a power consumption of 1 watt for 1 hour. Total watt hour rating of the system. Total connected load in watts that we had already calculated, and operating hours. So it is given that it is the operating hours is 6 hours per day. So it is, and we had calculated this 156 into 6. So total watt hour is 936 watt hours. Now, if you want to make it 4 CFL, 5 CFLs, or maybe some other equipment, you just keep on adding them. This is just a simple example which it is giving only 2 things, CFL and fan. So you have calculated the watt hour is 936 watt hours. This is the power. Then output. Actual output of a PV panel is equal to peak power rating. Actually, over here, this 40 is an assumption.
Yes, sir.
Peak powering rating into operating factor. It is the operating factor cannot be 100. It will be less than 1. 100 means 1. So it is only 40 into 0.75. So this is coming to 30 watt. The power used at the end use is less due to lower combined efficiency of the system. Actual power output of a panel into combined efficiency. So here it is 30 into 0.81, because when I'll show you the assumptions which have been taken. So in that it is 0.9 into combined efficiency is 0.9 into 0.9. So it is 0.181. It is 24.3 watts. If you multiply this, you'll get 24.3 watts. Energy produced, the actual power output into 8 hours day. If you're taking 8 hours day, peak equivalent. So it is 24 into 0.3 into 8, which is coming to 1. The actual, we were calculated, that was the maximum, 196. But actually, it will be 194.4 watt hours. So what is the number for producing this much load? How many solar panels you will be requiring? Number of solar panels required to satisfy given estimated daily load is total watt hour rating, daily load divided by daily energy produced by the panel. So this we had calculated 936. So actually it was 936, the optimum level, but we were only, actual power output is 194. So it is 936 divided by 194.4, which is equal to 4.81. 4.81, we cannot have fraction panels. वो तो डिजिटल मतलब ये होगा ना, कंटिन्यूअस तो नहीं है, 1 होगा, 2 होगा, 3 होगा, 4 होगा. तो इसीलिए we have rounded because it is 4.81, which is near to 5. So this has been rounded off to 5. So for producing that much of energy, you require 5 solar panels. And now this is for a small example. For a big power plant, you will be requiring so many panels. So naturally, you will be, the total load being produced will also be much more than what is given in this example. Inverter size is to be calculated as total connected load to PV panel system. We had calculated this 156 watts, and generally inverter, they come into 100, 200, 500. So according to which is nearer to this 200, because 500 will be more and 200 will be much less, because 200 is available, 100 will be much less. So this is the best. So therefore the choice of the inverter should be 200 VA. Now cost estimation of a PV system. Cost of arrays, number of PV modules into cost by module. So we had calculated 5 because it was coming to 4.81. So rounding off, it was coming to 5. And 8,000 for 40.
What panel?
What
Panel?
panel at the rate of 200 per WP. Cost of battery, number of batteries into cost module. So it is 1 by 7,500. These are based on some assumptions. 7,500. Cost of inverter, number of inverter into cost by inverter, that is coming to 1 by 5,000. So it is 5,000. The total cost will be cost of array, cost of battery, and cost of inverter. All together, it's giving you 52,500. Because in the cost, you'll be taking the cost of arrays, the cost of batteries, the cost of inverter, everything, because these are the components of a solar plant. So you have to take the total cost into consideration. And another additional cost of wiring may be taken as 5% of the total system cost. So 5% of this 52,500 plus 5% of 52,500. That will be the cost for wiring. That is an estimate. Now, what are the assumptions? Inverter converts direct current into alternative current with efficiencies about 90%. So this is one efficiency, that is 0.9. Battery voltage used for operation is 12 volts. The combined efficiency of inverter and battery will be calculated as combined efficiency. Inverter efficiency and battery efficiency. So it is 0.9 into 0.9. That is why you are, in that calculation, it has come to 0.81, 81%. Sunlight available in a day is 8 hours per day, equivalent of peak radiation. And operation of light and sun fan is for 6 hours per day of PV panel. So these are the assumptions which have been taken. PV panel power rating is 40. We had used this 40 peak. What at peak? That is 40. This is an assumption. You can change this assumption, your answer will be different. Gives only peak power out of a PV panel. A factor called operating factor is used to estimate the actual output from PV module. The operating factor between 0.60 and 0.90 implies the output is 60 to 90% lower than rated output power. In normal operating condition, depending on temperature, dust on module, etc., affects the actual output. So this is how we calculate how many PV panels you will be requiring for producing the amount of electric energy which you want to produce. First, you have to see how much you are going to produce. How many things will be connected to it? What will be the consumption of each? How many and what is the energy they'll be requiring? So you first calculate the total load, and from there you calculate the number of PV panels you will be requiring to produce that load. Then, just like any operation, the first consideration is where it should be located. ऐसा तो नहीं है ना कि सोलर पावर प्लांट हम कहीं भी लोकेट कर दें, कहीं भी तो नहीं लोकेट कर सकते ना.
Yes, sir.
Because the requirement of each operation is different. जैसे एक ऑटोमोबाइल, जैसे हम लोगों ने ऑपरेशंस मैनेजमेंट में किया था कि you have to see at so many factors, whether it is like for example if you are producing automobiles, तो उसके जो रॉ मटेरियल हैं वो कहाँ से अवेलेबल हैं. Should it be located near the raw material or should it be located near the market? जैसे पहले जब जमशेदजी टाटा had built a heavy engineering plant at Jamshedpur, Tisco, तो क्या था, क्यों किए थे? Because the raw material was available there. झारखंड एरिया में रॉ मटेरियल था, इसलिए they came all the way from Bombay to set up their plant at Jamshedpur. But now that is not the case. Moving raw material to the manufacturing unit is not all that difficult. That is why you have manufacturing unit at so many other places, which is very far from the raw material. So technology has changed. There are better transportation is there. So, but other factors, electricity supply कैसा है, government policies क्या है, land का price क्या है, all these things matter. But this is something, solar plant is something very peculiar, has very special features about it. So first of all, you have to see कि solar irradiation, solar का कितना radiation तुमको मिल रहा है. तो minimum for 1100 kilowatt per hour, you need area है per year, area in meter square it is given. Then certain slope and aspect. The slope भी होगा, जिस land पर the solar plant is being situated should have a slope between 5 to 15 degree. Aspect होगा, उसका क्या direction होगा चाहिए, south east, south, partly southwest. Transmission lines adjusted to capacity located nearby. Transmission line with equal and more than 35 kV around 600 meter nearby. Proximity to populated area is less than 25. बहुत दूर भी नहीं होना चाहिए, क्योंकि you have to supply it to some population. ये तो नहीं है कि आप बिराने में बना लीजिए, तो वहां से ट्रांसमिट करने में बहुत पैसा खर्च हो जाएगा. तो इट शुड बी, माने ये भी नहीं है कि एकदम आप पॉपुलेशन के बीच में उतना लैंड ही नहीं मिलेगा, तो लैंड की भी जरूरत है और पॉपुलेशन से नियर भी होना चाहिए. तो इट शुड बी प्रॉक्सिमिटी टू पॉपुलेटेड एरिया इज लेस देन 2500 मीटर. The data which I am giving you, it has been given by many analysts. Together they have worked on it and then they have come to these figures. Proximity to enterprises less than 35 meter. Proximity to road network less than 500 meter. जैसे उस डायग्राम में भी हम लोगों ने देखा ना कि ट्रांसमिशन लाइंस हैं, जिसके थ्रू फिर वो ट्रांसमिशन उसका होगा, जहां भी जाना है. तो कहाँ जाना है? इट हैज टू गो टू सम पॉपुलेशन, एंटरप्राइजेस हो या प्राइवेट हाउसेस हो, व्हाटएवर इट इज. तो इट शुड नॉट बी वेरी फार ऑफ कि वो ट्रांसमिशन में ही इतना पैसा खर्च हो जाए. तो कॉस्ट ऑफ इलेक्ट्रिसिटी विल गो अप. एवरेज एयर टेम्परेचर इन जुलाई, this is for northern, this research was done for northern hemisphere. So this is between 15 to 40 degrees centigrade. proximity to multi-story houses, that is more than 16 stories, is greater than 100. क्योंकि multi-story building से थोड़ा दूर होना चाहिए, because that hampers the effect of solar radiation on the PV panels. वो बैरियर की तरह काम कर देता है. तो ये शुड बी मोर देन 100 मीटर. बहुत उसके पास नहीं होना चाहिए. उनके पास बहुत मल्टी स्टोरी हाउसेस नहीं, मोर देन 16 काफी ऊंचा हो जाता है. जैसे छोटे मोटे 4, 3, 5 ऐसे हैं स्टोरी, मल्टी स्टोरी, तो इससे कोई फर्क नहीं पड़ता है. बट मोर देन 16 स्टोरीज है तो इट शुड बी ग्रेटर देन 100 मीटर्स. Proximity to residential area is more than 500 meters. और क्या नहीं होना चाहिए, वो तो ये सब तो होना चाहिए. बट जैसे लैंड कवर क्या होना चाहिए, इट शुड बी फ्री ऑफ माउंटेन्स, फॉरेस्ट, वाटर बॉडीज, बिल्डिंग्स, वेटलैंड्स, फूड ग्रेन्स, सॉरी फ्लड प्लेन्स. इससे ये नहीं होने चाहिए उस जिस लैंड पर आप सोलर प्लांट बना रहे हैं. Preferably low and medium grassy vegetation, shrub lands, barren lands, closed landfills, abandoned mine land. ये these are better. जो protected areas है वहां भी आप नहीं बना सकते हैं solar power plant. National and regional parks, areas of cultural heritage, ये सारे जगह आप नहीं बना सकते हैं, because they are meant for something else. And these should be protected from being misused by some other manufacturing unit. Yeah, what are you manufacturing? You manufacturing electricity using solar energy. It should be quite far from shoreline. माने नदी या समुद्र के से भी काफी दूर होना चाहिए, लेकिन that starts affecting the working of the solar plants. High altitude areas से भी दूर होना चाहिए, because as the 16-story building है उससे दूर होना चाहिए, तो naturally high altitude areas भी उसको उसी तरह affect करेंगे, तो उससे भी काफी दूर होना चाहिए. So these are the explanation. To be economically viable, photovoltaic system typically requires solar irradiation in an amount of 1100 kilowatt hour per meter square per year. ये एक इससे ज्यादा भी हो सकता है. Requirement can be more than this, but this is the minimum. इससे फिर इकोनॉमिकली वायबल वो सोलर पावर प्लांट नहीं होगा. इतना भी एनर्जी नहीं वो प्रोड्यूस करे तो बेकार है. With regard to you read it, any one of you, Shashi, Subir, क्योंकि ऐसा नहीं है. It is just the explanation of the data which I had given earlier.
Okay, ma'am. With regards to slope of the terrain, in general, flat land is most suitable for solar sites. Steep slopes make construction difficult and more expensive. With the increase of the slope, the complexity of the design increases, which often leads to a proportional increase in cost installation of photovoltaic the panels on steep slopes can cause problems related to erosion, the drainage systems, and the stability of the foundation. The slope of the Earth's surface affects surface affects both conditions of optimal orientation
Orientation,
and and
inclination.
and inclination of PV modules and the technical component of a technical slope that makes installation technically feasible. Feasible is 15%. If the slope is small, then the কি হলো? Sir?
15% तक slope पर
हाँ, एक
technically
मिनट
you will have problems. If it is more than that,
हाँ,
there will be technical
हाँ,
problems. There will be
हाँ,
environmental problem. जैसे it will lead to erosion, drainage system, stability of the foundation. All these things will be affected. So इसीलिए slope बहुत ज़्यादा hilly area या slope जहाँ बहुत high है वहाँ नहीं जाना चाहिए.
Whereas on steeper slopes, slope orientation is a deterrent, and in this case, solar power plant could be built only in the south-oriented areas. In literature, there is a wide variation of slope values considered suitable for solar power plants. मतलब ये साउथ ओरिएंटेड होना चाहिए, एरिया में होना चाहिए.
ऐसे जनरली स्लोप कम होना चाहिए, और वो क्या होना चाहिए, लिटरेचर में बहुत सारे वेरिएशन है. कोई कुछ कहता है, कोई कुछ कहता है. क्योंकि ऐसा है ना कि देखिए, इट इज ऐसा तो नहीं है कि आज आपने इतना बड़ा सोलर प्लांट लगाया और कल वो आपको बंद करना पड़ेगा. यू हैव टू सी ऑल दीज थिंग्स बिफोर एक्चुअली गोइंग इट. उस स्लोप से आपको क्या क्या प्रॉब्लम हो सकते हैं. You have to see that, analyze that, take the opinion of experts, because these are very technical problems. So this is when you are just setting up the power plant. क्योंकि अभी तो उसके बाद you have to maintain its maintenance, its quality, its electricity is needed, तो forecasting की जरूरत होगी. तो ये सारे चीज हम लोग टेक्निक्स पढ़ते हैं ना ऑपरेशंस मैनेजमेंट में, कि फोरकास्टिंग आप कैसे करेंगे. तो ये सारी चीज यू विल रिक्वायर इवन फॉर द सोलर प्लांट. शशि,
टेम्परेचर.
शशि.
Yes, madam. Air temperature directly affects the performance of solar power plant and the period of its operation. Electrical parameters of any solar cell are determined by the so-called standard testing conditions, such as when the solar radiation parts point meter square.
सोलर रेडिएशन जो होता है आपको 1000 watt per meter square, and panel operating temperature is -25 degrees centigrade. Then the optimum air temperature should be between 15 to 40 degrees centigrade. All these things had come in the chart which I have given you, कि कितना उसका टेम्परेचर क्या होना चाहिए, उसकी प्रॉक्सिमिटी कितने सब चीजों से कितनी, उसकी किस टाइप ऑफ लैंड होना चाहिए. These are the mostly, because of these things some technical problems might not arise. स्लोप से फिर कॉस्ट भी राइज होगा, टेक्निकल प्रॉब्लम्स भी हो जाएंगे, जैसे इरोजन हो गया, ड्रेनेज हो गया, your foundation will become weaker, all these things because of drainage and erosion.
Yes, sir. The issue related to the proximity of a site for the solar plant to a power supply line is considered an economic factor. It reduces the cost of installation and creation of a new infrastructure. the closer a project is located to existing power lines, the cheaper it will be to connect it to the grid, and the lower line loss and transmission expenses.
Also, it should be the proximity जहां से transmission lines जा रहे हैं उसके पास होगा तो it will be cheaper also and viable भी होगा आपका. Easily you can transmit your energy through these transmission lines to wherever it is required.
Yes, sir. The solar PV utility with a capacity of less than 15 megawatts requires a nearby power line of 35 kV, while solar utility with a capacity of over 15 megawatts require a special high voltage transmission line over 35 kV.
तो जितना उसकी कैपेसिटी है उसके हिसाब से पावर लाइन की रिक्वायरमेंट होगी. कम है तो कम, ज्यादा है तो ज्यादा.
Okay, ma'am. A number of studies consider solar PV farm sites closer to area of high electricity demand, that is cities, village enterprises, to be more desirable because they minimize the distance electricity would have to travel and reduce associated line loss and transmission expenses.
This so I have already discussed. So it should be near to the place of consumption. तो transmission loss या जो भी transmission में expenses होंगे, transmission expenses, that will not be very high.
Okay, ma'am. Because roads are expensive to build, selecting sites closer to road is cheaper and can minimize the environmental impact associated with building new roads. The existing road network must be suitable for the transportation of material needed for the construction of solar power plants. Also, potentially suitable land should have road about 3 meters wide for the appropriate maintenance of the farm.
Because the plant will require material. ये तो नहीं जो isolation में काम करेगा. तो it should be near to good roads. अब ये नहीं है कि ऐसे जगह में ऐसे विलेज में बना दिया कि जहां पर या तो आपको फिर रोड्स बनाने पड़ेंगे नए to connect it with the source of material. So if it is possible, it should be near to roads which are useful for them. ये नहीं कि roads तो हैं but they are very narrow or not very well constructed, then bringing the materials to the solar plant will be difficult.
Difficult, yes, sir. Multi-story houses may block sunlight from reaching of a solar farms in at a certain times of the day. This factor directly affects the performance of solar power plants. Therefore, it is appropriate to set solar PV plant away from this type of building. Okay.
जैसे कोई हाई बिल्डिंग हो या कोई हाई एल्टीट्यूड माउंटेन हो, ये सबसे दूर होना चाहिए. तो फिर वो जो रेडिएशन सोलर पीवी सेल को मिल रहा है, that will be affected.
Yes, ma'am. While some studies consider it desirable for projects to be close to urban area with high demand for electricity, others consider it is undesirable to be too close to residential area. The main reason for this concern were the increased potential for none in my backyard opposition and the possibility of impeding urban growth. Land use and ability may be an issue both in terms of the actual PV plant site and along the main transmission line interconnection route.
जैसे ये तो कहते हैं कि it should be near the population where it is being consumed, but इतना भी पास नहीं होना चाहिए कि क्योंकि अर्बन भी तो ग्रो कर रहा है ना. अब इतना बड़ा प्लांट यदि बगल में बन जाएगा तो उसका ग्रोथ नहीं होगा. तो it has to some trade off has to be there. कि कुछ लैंड
Yes,
छोड़ना
sir.
पड़ता है क्योंकि फॉर द ग्रोथ ऑफ द अर्बन एरिया.
Yes, sir. This issue need to be addressed early enough in the process to avoid any problem during the operational phase.
तो ये सब प्रॉब्लम्स हैं, तो ये प्रॉब्लम को पहले ही सॉर्ट आउट कर लेना चाहिए, नहीं तो लेटर ऑन इट विल क्रिएट प्रॉब्लम. ऑपरेशन आपका जब शुरू हो गया तब ये चेंजेस करने से तो बहुत प्रॉब्लम हो जाएगा. मान लीजिए आपका वो सिटी जो डेवलपर्स हैं उनसे प्रॉब्लम हो गया, वो कह के नहीं मुझे सिटी को बढ़ाना है, वहां लैंड ही नहीं है, इट हैज बीन टेकन अप बाय द सोलर पावर प्लांट. तो एक बिफोर स्टार्टिंग द ऑपरेशन ऑल दीज इश्यूज शुड बी टेकन केयर ऑफ. हाँ सुबीर. क्या हुआ सुबीर?
Yes, ma'am.
टिपिकली
Typically, the transmission line crosses many plots of land held by different owners, which can present a challenge to purchasing or leasing the land. This can ultimately result in some access or availability restrictions or restriction to properties along the preferred route. Thus, it is important to check in depth the cadastral documents, ownership titles, and land easement agreements. Regarding
तो
land
see,
cover,
अब ये तो
हाँ.
काफी दूर तक जाएगा ट्रांसमिशन लाइन. अब ये इट
Yes.
विल बी क्रॉसिंग सो मेनी plots which can be owned by different parties. So you have to have a good agreement कि later on there should not be problem.
Yes.
उसमें anyone it cannot be forced. It has to be an agreement between the owner of that land and the power plant.
Yes, ma'am. Regarding land cover, potential suitable area must be free of mountains, forests, water bodies, buildings, wetlands, floodplains, and preferably has low or medium grassy vegetation or shrublands.
Shrublands जहाँ छोटे छोटे थोड़े झाड़ी झंखाड़ जहाँ हो रहे वो ठीक है, मगर हाईली नहीं होना चाहिए, फॉरेस्ट नहीं होना चाहिए, वाटर बॉडीज बहुत ज्यादा नहीं होना चाहिए, हाई राइजिंग बिल्डिंग नहीं होना चाहिए, वेटलैंड्स नहीं हो जाना, फ्लड प्लेन्स नहीं कि वहां बहुत ज्यादा फ्लड आ रहे हैं उस एरिया में. तो दैट ऑल दिस शुड बी अवॉइडेड व्हेन यू आर सेलेक्टिंग द साइट फॉर योर पावर प्लांट.
Solar parks are not typically proposed in landscapes designated for natural beauty or protected areas of archaeological or ecological importance. Nevertheless, a careful assessment of these types of potential fatal flaws should be performed early in the project feasibility stage.
So these things also, like in that chart which I had given you, the table, this is also mentioned कि अब जो protected area है, जो landscape बनाया गया है अच्छी तरह या protected है या ecological importance है उसका, तो यहाँ ये सब these lands should be avoided. So right in the beginning these things should be taken into consideration.
Yes, ma'am.
Distance at least.
Distance at least 1,000 meter from a solar line could protect a solar farm from consequences of natural disasters. Another reason to avoid seaside areas when installing a solar farm is their higher price, making such installations less cost effective. In addition, high altitude areas have higher transportation cost and are not preferable.
So it should be far from seashore, क्योंकि वहां से natural disaster the sea में कुछ होगा तो the power plant will be affected. और फिर वो एरिया भी ज्यादा महंगा होता है. To make it cost effective, it should be quite far from the seashore, more than 1,000 meter. And even high altitude areas should be affected. एक तो वो problem ही है, technical problems तो होंगे ही. Plus, the cost of transportation will go high. That will increase. Altitude पे कोई चीज higher altitude पर आपको कोई सामान ले जाना है तो transportation cost will be more. So that way these things should be avoided. So you have to select a land which is not very near the sea, which is more or less plain. ठीक है, थोड़ा बहुत shrubs हैं या grass है, बड़े बड़े grass है, तो that does not matter, and it is getting abundant sunlight, and it should not be very far from the place of consumption and not very near to the place of. So all these trade-offs you have to see before you start the operation, before you select the land from where you want to make your power plant. So first of all, any startup, it is where to make, because it is what? A manufacturing unit. कोई service unit नहीं है. It is a manufacturing unit. So it should be started at a place where in the future there will be no controversies. Problems होंगे तो फिर it cannot be redone. वो एक बार हो गया तो हो गया. उसके बाद ये तो नहीं है कि आप वहां से उसको शिफ्ट कर देंगे, नहीं कर सकते हैं. तो all these things before you start the building the power plant, all these factors should be taken very very seriously. Feasibility study बनाते हैं, उसमें हम देखते हैं कि whether it is economically feasible, whether it is socially feasible, whether it is technically feasible, whether it is environmentally feasible. All these feasibility studies करके ही opinion of so many people are involved, experts are involved, and then you have to also see what will be the total capacity, how much electricity it will be able to produce, and what is the demand for electricity. How much, because electricity is produced through so many different means. So how much is, because this is a non-conventional way of producing electricity. It is sunlight, which will not die after a few years. It will be there. So in the long run, this will be much more beneficial than thermal electricity or hydroelectricity. So, but before doing this venture, you have to see that it is being produced in a land which is suitable for it, where it can produce whatever it is doing in peaceful manner, the least hassle. And apart from that, day-to-day hassle to hoga hi. You have to maintain the equipment. It should be in a very good quality. It should have the quality, the cost, all these factors, which is there in any operation. All these factors, especially quality, cost, and maintenance. These things has to be seen by the people who are in the operating system of the solar plant. Apart from technical knowledge, how it will be produced, that is the technical knowledge. But maintaining the power plant, apart from, it is not that they should not have any technical knowledge, but apart from them, they should have the managerial knowledge. of how to maintain that solar plant so that it is producing the maximum, whatever it is, that its capacity, full capacity, and it is fulfilling the customer demand also. So you have to see if there is a match between demand and supply. That is one area where management plays a very good role. It matches the supply and demand. So things are not, if it is producing too much, then whatever it is being demanded, so things will be wasted. If it is producing less than what is being demanded, so many unfulfilled demands will be there. So you have to see the principles of operations management is also playing a vital role over there in maintaining that solar plant. Do you have any other questions?
No, ma'am.
No.
Where is Subir?
Yes,
Yes,
ma'am.
ma'am.
Subir is there. I mean, Shivam.
Yes, ma'am.
Since you are from this particular area, just throw some light on it.
Ma'am, for the solar power plant, I am not there. Actually, I am making the modules, the panels.
Pardon?
So, hello.
Where are you working, Subir?
Ma'am, Adani Solar.
Pardon?
Adani Solar, ma'am.
Oh. So,
Ma'am,
have
Adani
you
Solar.
any idea how that site was selected?
No, ma'am. That was not. मैम दैट द थिंग्स दैट आपने जो बोला मैम कि फ्लैट लैंड रहना चाहिए, वो सब मैंने देखा हुआ है. अभी प्लांट एस्टेब्लिश्ड हुआ है एक गोंदिया महाराष्ट्र में एक प्लांट हुआ है.
हाँ.
अभी जस्ट हुआ है, मतलब लैंड फाइनल हुई है, तो लैंड कंप्लीटली फ्लैट है एकदम, मतलब फ्लैट लैंड सा जो आपने जितना चीज दिखाया है वो चीज सेम चीजें वो सब वहां पे भी होती है. कुछ 300 किलोवाट का प्लांट है कुछ में वो, तो उसका ऑर्डर है.
तो हमने इसलिए ये लिया क्योंकि दिस इज द फर्स्ट स्टेप यू हैव टू टेक व्हेन यू आर स्टार्टिंग एनी ऑपरेशन. फर्स्ट स्टेप ये है कि कहाँ उसको बनाना है. सब चीज को ध्यान में रखना पड़ता है ना, कि कहाँ वो मार्केट होगा, कहाँ वो पीसफुली आप बना सकते हैं, कहाँ वहाँ उसका ऑप्टिमल, क्योंकि इसमें बहुत सारे प्रॉब्लम्स हो सकते हैं ना. एनवायरमेंटल प्रॉब्लम्स हो सकते हैं, टेक्निकल प्रॉब्लम्स हो सकते हैं. The amount of sunlight reaching that panels is not sufficient. So all these things you have to take. You have to take the environmental factors into account. You have to take the technical factors into account. You have to take the socio-economic factors also into account.
Yes, ma'am.
All these things you have to take into account before you start the producing the solar energy.
Solar panels. Yes, ma'am.
So that it is converted into electric energy and people are using it. Because see, for me also, like especially for solar plant, I had to also do a lot of reading.
Yes, sir.
Because I am not from this particular field. Because in operations management, we show you a general way. What are the different aspects you are seeing in your operations management. But how those things are being applied in solar plant, that you have to apply those techniques, whether it is forecasting, whether it is quality, whether it is maintenance. Because see, if the equipments, there are so many components, each and every component should be at its optimal level. The maintenance of all and it has to be preventive maintenance. Because anything goes wrong and the particular part is shut down, the production will be affected, and
Yes,
with
ma'am.
that the consumers will be affected. So that preventive maintenance over is very important. Regular checkup of all the equipments, both manually as well as technically, you have to check and see if all the equipments are working properly, they are in proper order, whether they are inverter, whether they are transformers, whether they are batteries, whether they are solar panels, whatever it is. The different components have to be in the optimal level of service, so that whatever is your desired load is being produced constantly, and it is being consumed by the consumers also simultaneously. There is no mismatch. Nothing is being wasted and nothing is being overproduced. As far as possible, it cannot be 100% matching, but as far as possible. That is the
Yes.
goal of matching supply and demand. Any other question? So next, we'll take up a working of a automobile sector,
Okay.
because that is not very difficult, because see, automobile sector is quite old. Solar energy is something very new.
Yes, sir.
So operation of a solar energy requires lot of things which it is not that it is being required over here, it is not required by that, but the availability of literature, that is missing over here. How to maintain it, how to operate it. These things are not all that easily available as it is available for an automobile industry. And then we'll be doing on the last Saturday, we'll be taking up e-commerce, operation of an e-commerce enterprise. Okay,
Okay, ma'am.
I hope you are satisfied with this presentation.
Yes, sir.
Yes, ma'am.
Okay, good night.
Good night,
Have a
ma'am.
nice week.
Good night, ma'am.
Good night. Goodbye.